So, hello everyone. My name is Lehei Wenmei, and I'm a part of cohort 26. So today I'm gonna present to you guys my final project for computer organization course. And for this project, I did a 10 chaotic log, and so I'm gonna briefly talk about it. So the combinational lock is a widely used tool for managing authorization and protecting properties. So the motivation for the project is to enhance security by adding an attempt counter which limits the incorrect attempts and triggers alerts for potential breaches. This feature is valuable in applications like door locks and security vaults, ensuring better protection and access control. So let me walk you guys through a brief description of the project. So this project is acted like a normal combinational lock. It will reset the reference password first, and the reference password will have 6 bits, and user will need to enter 6 bits as to trying to unlock the system. And the system will compare the user's input and the input that the system had been stored, and if the result is correct, it will unlock. Otherwise, it will remain locked. And after 3 attempts has been exist, the alarm will turn on to signify that there is someone trying to get into the system. And that there's someone who not supposed to get into the system and trying to get into it. So for this is the final state machine diagram. This is the init state, which is mean there is no signal at all. And when the user entered the password for the first time and they get the password wrong, it will turn to the next state. Here, the first number here is the correct or incorrect signal. If it's correct, the number here will be 1, and if it's incorrect, the number here will be 0. And in this case, the password is incorrect, so it is 1 here. And the second digit is the submit signal. If it is 1, it means that the user hit the submit button, and if 0 isn't, the user didn't hit it. So it's incorrect, and the user hit the submit button will turn to the second state, which is would announce that the user had entered wrong for the first time. And then if they do it wrong for a second time, we would turn to the next state, and the third time we turn into the fourth state. And if it's still wrong, the alarm will be turned on. And this alarm will can only be turned up if the user enter the password correctly. Otherwise, it's just still remain, the alarm will just ring it. And between the wrong attempts, if the user enter the password correct, the system will unlock. And when the system unlock, the green LED light will be turned on. And when the system is locked, if the user hit the submit button again, it will reset the whole system into the init state. So here's the binary modeling of the state diagram above. In this state, the first attempt, second For the input, we have to input the checking signal correct or not correct, submit signal or reset, will submit or not submit. And the output a lock or lock. So here's the block diagram of the system. I'm gonna implement it in a more machine. So the first combinational circuit, it will check this one is the user input and this one is the reference password. If they are the same, then it would the correct or not correct signal will be sent here. And this is the submit button. If the user hit the submit, the signal will also be sent into this one. And this is the state, the state, the next state, and this is the past state. It will pass like this. And the CS circuit, the second CS circuit, will display the output. Here green is unlock and red it still remain lock. And of course, this is the 3 attempts. So let's come to the truth table. In this, for the expression, I use the SOP. Here there are 4 number 1 here, so I use SOP to get this term to build the expression for the S2 right here, and I simplify this expression by using basic Boolean expression and De Morgan law. And this is the output of the table. Here the initial state of first wrong, second wrong, third wrong, correct, and alarm. Only in the correct state that the system unlock. However, as you can see here in the block diagram, we can also see if the system is locked or unlocked. But I want to display how many attempts the user have, how many remaining attempts the users have. So I train a bit the circuit and use the decoder instead. So for the light one, which means the user still enter the password wrong for the first time, and the LED 2 will be turned on if they got wrong for a second time, and the third one will be wrong for the third time. And this is unlock. Of course, it means the user input password is correct, and our left 5 mean the previous 3 attempts is wrong. So this is the truth table, and here's the expression of this circuit. So I implemented the circuit in circuit first, and this. So firstly, I built the memory, and the most basic component to create memory is the flip-flop, and I use master flip-flop in order to allow the system to read and write data. So here's the most basic component of the memory, and then as the state, binary state is represented by 3 bits, so I put 3 master slave flip-flop in order to build the memory. And using the expression above from the truth table, I create this logic and put it into the memory and then generate this, and the output of the memory or the transition here is going to be plug into the system again to determine the status. So this is the the state transition controller. And for displaying the output, I use the decoder, and here is the circuit of the decoder. And if you want this is the user input, and this is the reference password. We will need to set up this password first, and then check it with the user input. And in this case, the user input is wrong, by the way. And this is the whole system. So let me. Oh, one thing. There's one thing. Yeah. Oh, yeah. Right. I have already mentioned this because I want to display not only log or unlock, so I change it a bit to get like more detailed feedback from the system. So now I'm gonna walk you guys through the demo of the project on Circuit Bus, and it will be in the next video.